Today we are going to be reviewing states of matter and changes of state. Please open up your blue Physical Science Review packet and turn to page 4. Now, you're going to have to follow along with me closely today because we're going to be jumping around just a little bit in between the two pages. One with a triangle on the top with a snowman, an umbrella, and clouds, and then the second page that says Review of Changes of State on the top, and then there is a chart on the bottom. Let's first talk about states of matter. Let's look at solids. Now, look at this configuration right over here on the right-hand side of the screen. What do you notice about this solid? One thing you might see is that solids have a definite shape and a definite volume. This means that their volume and shape do not change. Why is this? Well, it's because their particles are packed close together. Do you see that? Do you see how each of these particles is very, very close together? This is because they have a very strong attraction to one another. Remember our analogy this fall where we talked about how solids were like molecules in a relationship, meaning they liked each other, like they wanted to be right next to each other, bumping side by side, where there was very little space for them to move. This is why solids keep their shape and their volume. Because the particles are close together, because they have a strong attraction, they really don't move that much. So we say that they have very low energy. And all of these things combined mean that solids keep their shape. Now, this isn't the same thing when it comes to liquids. Look at the image now on the right of a liquid. Look at the molecules. Look at how close together they are. When we talk about liquids, the particles can actually move around just a little bit. Why is this? Because liquids have what we say a fixed volume, which means that you could, measure them in something like a graduated cylinder or a beaker, but they don't keep their shape, which means you could pour a liquid from one container to another and they will take the shape of whatever container they are in. But you might be wondering, why is this happening? Well, it's because the particles in a liquid, they're not so attracted to each other. So they're not really, really close together, right? Because of this semi-attraction, there's just a little bit of space in between the particles. And that little bit of space allows the particles to slide and roll past one another. Think about liquids like your friends, right? You like your friends, you want to be around your friends, but you really don't want to be touching your friends, right? You have that personal space bubble thing going on. And that's what happens with liquids. Because the particles are around each other, they keep their volume. But because they don't like each other, they have some space between one another. And because of that, it's easier for molecules to roll or slide past one another, which means that they can't keep their shape. So when we talk about liquids, we say that they have medium energy. Because these particles can roll and move, their energy level would be considered medium. Now let's talk about some ways that we could change the energy level of liquids, make them have higher energy or lower energy. All of this happens with a change in temperature. And this affects the viscosity of liquids. And you might be wondering, what in the world is viscosity? Well, you learned that this fall. Viscosity is really looking at a liquid's resistance to flow. So viscosity is determined by the amount of attraction between particles. The more attracted the particles are to each other, the closer together they are. The closer together the particles are, the harder it is for them to move, which means the harder it is for them to flow. So when we look at things with high viscosity, that means that they flow really slowly. Why? Because they have a higher attraction to one another. They're closer together, and it makes it harder for the particles to squeeze and slide past one another. So these objects right here are showing you things with high viscosity. Honey or syrup, I would say, has medium viscosity. If you want to look at things with low viscosity, well, low viscosity means that the particles have more energy. And when they have more energy, they also have more space between them. And so when particles have more space between them, it's easier for them to flow or slide past one another. And when it's easier for them to flow and slide past one another, it means it pours more freely. So things like water or oil would be things with low viscosity. Now, if you want to change the viscosity of things like, I don't know, your honey that's been sitting in your cupboard for 4 months and has become very thick, well, all you have to do is add energy. So what do you do to your honey that's a little bit too viscous? You put it in the microwave, right? And when you put your honey in the microwave, you add energy. And when you add energy, the particles move faster, they move farther apart, and it makes it easier for the honey to flow. Why? Because it now has lower viscosity. Let's look at another property of a liquid, and that would be surface tension. Surface tension is really the tension that happens at the surface of a liquid. It kind of makes the liquid have something like a skin on it. Why is this happening? Because this tension is an inward force or pull. It's the idea that all the molecules on the surface of a liquid are really binding closer together, right? Why are they doing this? Because they're all trying to push inward. And this push inward actually makes this tension at the very, very top of a liquid. And that tension is the reason that things like water droplets form, is the reason that lily pads can float on water even though they're more dense than water, or the fact that this creepy looking bug can run across the water. Surface tension. And now let's look at our last state of matter, which would be gases. Look at the molecules inside of this beaker. Really, it's an Erlenmeyer flask. Do you see how the space between the particles? Do you see how it appears like the particles are trying to fill up as much of the container as they possibly can? Well, that's because gases don't really have a shape, and they don't really have a volume. Gases have what's called an indefinite shape and an indefinite volume, meaning they will fill whatever container they were within. This means that gases undergo a change in volume very easily. Why? Because the particles aren't organized. The particles actually have a ton of energy. Remember in the fall when we talked about gas molecules, we talked about how they're like enemies, right? They don't want to be around each other. They don't really care about one another. They're moving as fast as possible. And this very high energy means that they cannot keep their shape because they have no attraction to one another at all. When we talk about gases and we talk about their volume, you need to remember that the volume of a gas is whatever space is within. But here's something that's kind of crazy about gases. You can compress them. You can actually take the molecules in a gas and with a little bit of pressure, you can push them closer together.